This is section 3.4, part A, exponential and logarithm equations. The I can statements for this section: I can apply the one-to-one property of exponential functions to solve equations, and I can apply the one-to-one property of logarithmic functions to solve equations. Your one-to-one property of exponential functions: as long as your base is greater than 0 and your base does not equal 1. If you have a base of b raised to the x power, and that's equal to base of b raised to the y power, as long as those bases are the same, we can say the exponents are equal. So if we have 3 to the x is equal to 3 to the 5th, since both of those bases are 3, we can just say x is equal to 5. On the next one, we need to actually get the bases the same first. 36 is x squared. 36 is 6 squared. When you have a power raised to a power, you multiply. So 2 times x is 2x, 2 times 1 is 2. Now that the bases are the same, we know the exponents are the same, so we can set 2x plus 2 equal to x plus 6. And now we can just solve for x. So if we subtract an x from both sides, we're left with x plus 2 is equal to 6. If we subtract a 2 from both sides, we're going to get x is equal to 4. On the next one, we want to get the same bases. Now 1/2 is the same thing as 1 over 2 to the first power. If you want to get a value out of the denominator to raise it to the numerator, you make the exponent negative. So this is the same thing as saying 2 to the negative first power raised to the c. 64 is 2 raised to the 6th power. And then taken to the 1/2. Remember, when you have a power to a power, you multiply. Negative 1 times c gives us negative c. 6 times 1/2 gives us 3. Since the bases are the same, we know the exponents are going to be equal. And we're going to get a value of c is equal to negative 3. Now we have the same one-to-one properties when we deal with exponential functions and logarithmic functions. So if we have log base 2 of x is equal to 3, we want to cancel the base, that log base 2. So we can make our values, our exponents. 2 raised to the log base 2 of x is equal to 2 raised to the 3rd. As long as you keep the bases the same, you can always take what's on your left side the equal and the right side the equal and make them the exponents. Now remember, 2 log base of 2 just cancels, and I'll just leave you with x. So x is equal to 2 to the 3rd power, or x is equal to 8. The first one here is a little bit different. Remember, ln is the same thing as log base of e. So we want to raise it e raised to that power. E and ln are going to cancel. So we know x is just going to equal e to the 6th power, and e to the 6th power is 403.4. On the next one, we do need to solve and get the log by itself first. So we are going to subtract 6 from both sides first. Now we have 2 times the log of 5x. So to get rid of that 2, we're going to divide both sides by 2. Now remember, if it just says log, this is the common log, so it's a log base of 10. So to get rid of that log, we're just going to do 10 raised to the log of 5x is equal to 10 raised to the 6th power. The 10 and the log base 10 are going to cancel, so we're just left with 5x is equal to 1 million, because 10 to the 6th is 1 million. We're going to divide both sides by 5. And x will just equal 200,000. On C, if we have an exponent out front, we can always bring it out front, become multiplication. So we have 3 times the log base 8 of x is equal to 12. Right now it's 3 times that quantity, so we're going to do the opposite and divide. Now this is log base 8, so we're going to make 8 our base on both sides and make what we have on each side of our equal sign our exponents. Because this is 8 raised to the log base 8, we know those are going to cancel. So we're going to have x is equal to 8 to the 4th, which is 4,096. So our one-to-one property of logarithmic functions is, again, as long as our base is larger than 0 and the base does not equal 1, then the log base b of x is equal to log base b of y. So if as long as those two bases are the same on both sides, then we can just say x is equal to y. So in this case, we have log base 2 of x is log base 2 of 6. Since they're both log base 2, we can just cancel those parts out, and we just know x is equal to 6. So on part A, before we can do this, there can only be one log on each side to be able to cancel those out. So we are going to have to condense on the right side first. Right now it is addition. Remember, when you condense them, it becomes multiplication. Now we're going to take that 3 and we are going to distribute it. Now on both sides, we just have a log base 4, so we can cancel those on both sides. And we're going to be left with x is equal to 3x minus 6. Now we're just solving for x. So we're going to subtract 3x from both sides. Now we're going to divide both sides by negative 2. And we're going to get a value of x is equal to 3. On the next one, we only have one log on each side, so we don't need to condense. Since they are both log base 3, we can go ahead and cancel those. And we can just say x squared plus 3 is equal to 52. Now we're going to subtract that 3 from both sides. To get the x by itself, we're going to take the square root. But since this is an even root, remember it's plus or minus. So this means x is equal to plus or minus 7. Now we do need to make sure we check for extraneous solutions. If we plug in an x value of a negative 7 squared gives us a positive 49 plus 3. You can take a log of that. But if it would have just been log base 3 of x plus 3, negative 7 plus 3 is negative 4, and you can't take a log of a negative number. So do make sure you check these to make sure there are no extraneous solutions. So another statement that follows the one-to-one property is called taking the logarithm of each side. To get rid of an exponent, you can take the log of both sides. That means you can bring your exponent out front, and then you can solve from there. So in this example, we have e to the x is equal to 3. ln and e cancel each other, so we take the ln of both sides. So the ln of e cancels. You're left with x is equal to the ln of 3, and then you can solve for x. If it's not an e, if this was just 8 to the x, if it's 8 to the x is equal to 16, we can just take the log of both sides. Now this is log of 8 raised to the x. Remember, you can bring your exponent out front. Now this is x times the log of 8, so we would divide both sides by the log of 8. And this would give us a value of x is equal to 1.3, repeating. So on the first one, this is going to be very similar to that one we just did. This is 4 raised to the x power. We need to get rid of that. We want to get the x by itself, but it's in an exponent. So we can accomplish this by taking the log of both sides. Now you could take the log or the ln. It doesn't matter. You'll get the same answer either way. Now since this is a log, we can take the exponent and bring it out front and make it multiplication. Now we have x times the log of 4. We want to get the x by itself, so we can divide both sides by the log of 4. And after we divide, we're going to get x is approximately 1.85. On the next one, because this is an e, we know ln and e always cancel each other, so we will take the natural log of both sides. Now that ln and the e will cancel each other out, so you'll just be left with 4 minus 3x is equal to the ln of 6. We want to get that 6 by itself, so we will subtract the 4 from both sides. Now it's important to notice that you're just taking the ln of 6, that parenthesis does need to be closed, and then you're subtracting 4 from that quantity. Now we have negative 3 times that, so we're going to divide both sides by negative 3. So x will equal the ln of 6 minus 4, and all of that divided by 3. And this will give us a value of x is equal to negative 0.74.